This is lesson 1.6, Networks and Graphs, Distance Matrices. In the last few lessons, we looked at adjacency matrices. They told you about how many edges there were between different nodes. A distance matrix tells you the weight of each of the edges between these nodes. So if I look at my distance matrix here, we read it the same way. Lawn tennis left top. So it tells me from 1 to 0, I've got a weight of 2. So I can see here, 1 to 0, that edge has a weight of 2. Let's go from 2 to 4. So node 2 to 4 has a weight of 13. So it tells me the weight of the edges between our nodes. So I've got a distance matrix here, and we want to draw out the associated network, the associated graph to this matrix. So let's look at all our different connections. So if there is no connection, we don't write 0. If we write 0, that means there's a weight of 0, but there is a connection. We just put a little dash if there's no connection. So there's no connection from A to itself. A is connected to B, and that's got a weight of 24. It's not connected to C or D, but it is connected to E with a weight of 23 and F with a weight of 22. B is connected to A, we've already got that in. It's not connected to itself. We've got it connected to C for 18. We've got it connected to D with a weight of 19. And we've got it connected to E with a weight of 17. And finally, F with a weight of 20. C is not connected to A. We've already got a connection with B. Our connection with D has a weight of 11. And our connection with E has a weight of 14. There's no connection with F. D, we've already got our connection with B. We've got our connection with C. We just need to add in our connection with E for 13. E, then we've got our 23, our 17, our 14, our 13, because you have those nodes done. The last one we're missing is the 21 with F. And then F, we're just going to double check we have all our connections. I've got the 22, I've got the 20, and I've got the 21. And that's my graph associated with this distance matrix. Let's try this one yourself. Fill in the graph associated with this distance matrix. There's our graph that's associated with this distance matrix. We can see we've got all our connections. So A to B for 7, A to C for 3, A to E for 8, A to F for 11. You've got B to A already done. We've got B to C for 4. We've got B to D for 2. We've got B to F for 7. C to A is done. C to B is done. C to D is 5. C to E is 9. D, the only one we're missing here, we've got our 6. And then our 3 going to F. E, we've got all our connections done. F, we've got all our connections done. They're not connected to each other. And that's my graph associated with this distance matrix. So we've got half a distance matrix here, and we've got the associated graph. I want you to fill in the numbers that we're missing. Right, so my connection from B to D, there's B, there's D. That's a connection of 24. I've got C to D. That's a connection of 22. And C to F is 29. We're looking at a few connections for D now. So we're looking for how D is connected to B. When we had that a minute ago, that was 24. How is D connected to C? We also had that for 22. And how is D connected to H? Well, that's 34. Let's move down here to F. How is F connected to C? We can see that connection has a weight of 29. How is G connected to E? So there's G, there's E, the weight is 26. And how is G connected to H? We've got a weight of 33. And then how is H connected to D? That's 34. And how is H connected to G? That's 33. And that's my distance matrix associated with that graph.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.